Hi guys, so taking notes for section or chapter 6.3. What are we supposed to be learning in this chapter? And I will say, if you guys just want to read the chapter on your own and do the examples and then try the checkpoints, that's up to you. I'm more than happy to have you do that. These videos are in case you need a little bit more explanation for what's happening. So what am I supposed to learn today? What are we learning? What are the objectives? Is we are using linear equations to solve problems, okay? And we are solving a formula for a variable. So instead of finding a number and substituting in a number, we're just kind of rearranging an equation there. Okay, so how is this book is starting us out? Focusing on how much money Americans earn. Don't get me started. Okay, so here are some strategies for solving word problems. If you watched my other video, I kind of simplify all of these steps into the word desea. Okay, how about dark green today? And that's how I remember it. And this is the way we've always taught it. I love that this book always breaks things down into steps. The steps we use that match up that we've talked about are define, so desea, S-E-A, desea, where D is defining your variable, which matches up to step 1. Okay, so until you can state in your own words what is given and what the problem is looking for, those are defining your variable. Let X equal, let Y equal. And I can tell you, going through my bachelor's and my master's in mathematics, that is literally the first thing I do for every problem. I don't even think about it. It's like I have to do it to understand what's happening. E is to write an equation, stands for equation, write an equation. Okay, and so that's step 2, write an expression or equation there. I guess they break it down into 2 steps, write an expression or write an equation. And we just have equation up there. So steps 2 and 3 kind of match up with the E. The S and E for me go together. They are solve or evaluate. So solve the equation or evaluate the expression. That's step 4. It's amazing how well these match up. And step 5, check the original wording of the problem, not in the equation obtained from the words. And our last step here is the A stands for answer, to answer in complete sentence. So whichever way you would like to remember is up to you. Desea has a lot less words, but you do have to remember what all of the letters stand for. These steps are pretty well written out that you might use to go back when you're solving something and check that you've done everything. So it is up to you. Here, the book, what I love this part of the book. I would either take a picture of this. I'd hate to see you write all of this down or put a sticky note in your book. But it talks about how do we translate the words in a word problem into math. And I really feel like for the past 15 years, this is what students struggle with the most. So if you're talking or you're looking at equation and it's talking about the sum of a number and 7, then we talk about taking some number we don't know, we call it X, and adding 7. I think we talked about this in 8.1 because to this day in my head when I'm doing percent problems, I always say something of, some percent of, like 40 is my equal sign, let's say 15, and we could solve that. But today in my head, I have to say the word of and then remember that it's multiply, and is always equals. So I still think this way in my head, like if I'm shopping or I'm doing tip or something like that. Okay, so this just goes through. I'm not going to read it off to you, but you might want to stop back on this page. Like I said, take a picture or put a sticky note in it in case you have a question when you're trying to set up a problem or translate a problem. So we can go through example 1 together. Again, you can do this on your own and skip to the part if you have any other questions where I go over things or help set up the checkpoint. The bar graph in figure 6.4 shows average yearly earnings in the United States by highest educational attainment. So as you can see, it's something we kind of always tell you in class, in school, that the more education you have, right, the more money you're going to make. It looks like this graph is also pointing out that females make make less than males for the most part. I'm sure that there are exceptions to that rule. I'm also interested in when this book was published and seeing if anything has changed, although I think that that's still true. And I will say that this does work for everything unless you are going into education. And education teachers are super well educated, but don't make as much money as they would make in a different job with the same education. Okay, so we're kind of looking at this bar graph. And the question is, let me make this a little bit bigger here. The average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by about $45,000. Okay. Combined, 3 men with each of these degrees earn $214,000. Find the average yearly salary of men with each of these levels. So the first thing they do is define their variable. They said X is equal to the yearly salary of a man with an associate's degree. And the reason they chose a man with an associate's degree is because each of these, what's the word I'm thinking of? Each of these men, right? They're talking about they look at the bachelor's degree versus the associate's degree. And then they're also looking at the master's degree versus a man with an associate's degree. So when we're looking at both of those men, the man with an associate's degree and the man with, the man with a bachelor's degree and the man with a master's degree, they're always comparing it to the man with an associate's degree. So that's why they made, that's why they made X equal to the average yearly salary of a man with an associate's degree, because then we can represent the other 2 men's salaries using the same variable. We just are comparing both of them to X. And then we only have one variable, and that makes it a lot easier to solve. Okay, so that's why they came up with that. Step 2, represent other unknown quantity in terms of X. This is what I was just talking about. So we're going to represent the man with the bachelor's degree in terms of X. And that's really important. I'm going to write that over here to remember. In terms of means how is it comparing to the variable that it's talking about in terms of. Okay. And here, with a master's degree, both of them in terms of the associate's degree. So with the bachelor's degree, if X is the associate's degree, then you have to add on $25,000 to be able to represent the salary of a man with a bachelor's degree. And here X is still represents the man, how much money the man makes with an associate's degree. And then whatever that is, we can add on $45,000 and you get the average yearly salary of a man with a master's degree. Okay, so both of those salaries are written in terms of whatever the person with the associate's degree is making. Okay, then we're writing an equation, an X that models the conditions. Okay, so it is talking about you take the man with the associate's degree, you add the salary of the person with the bachelor's degree, which we represented as the associate's degree plus $25,000. Then we add the salary of the person with the master's degree, which was the person with the associate's degree plus $45,000, and it equals $214,000 because In the word problem, it said combine, which means to add up. 3 men with each of these degrees earn $214,000. So they used the word earn as the equals sign. Okay. And then they just solved this equation. So they just combined their like terms. They have 1, 2, 3 x's, and then 25 plus 45. So this is in terms of thousands of dollars. So we don't have to write all of the zeros after those dollar amounts. But 25 and 45 is $70,000. And subtract 70 from both sides, and you get 3x is equal to 144. And then divide both sides by 3, and you get x is equal to 48. Now remember, that stands for $48,000. So we know that the average salary for someone, for a man with an associate's degree, is equal to $48,000. Then we put that 48 back in where we see x. So the person with the bachelor's degree, you have to add on $25,000. So their salary is $73,000. And then to find the salary of a man with a master's degree, again, we have to take that amount that the associate's degree is making, which is $48,000. And this time we add the $45,000. And this time we get $93,000. Okay. Men with associate's degrees, and this is just talking about what I just said. And then it says to check your problem. So they just added them together, and when they added them up, they got $214,000. Okay. Where's our checkpoint? There we go, checkpoint 1. Let me help you figure out how to set it up. The average yearly salary of a woman with a bachelor's degree exceeds the woman with an associate's degree by $14,000. And so they are comparing a bachelor's. This time we're thinking about women. They're comparing a bachelor's and an associate's. The average yearly salary of a woman with a master's degree exceeds that of a woman with an associate's degree by $26,000. So they are comparing both the bachelor's and the master's to the associates. So I think you know where I'm going to go with that. Our variable, let x equal the amount or the salary of a woman with an associate's degree and let's just put in there in thousands of dollars, and that way we can just use those numbers without all the zero. In thousands of dollars, period. Okay, and then we have the word combined, remember, so we're going to add. We're going to add, combining all of their salaries. They earn $139,000. Well, that's a lot less than $214,000 from the men's, isn't it? And so find the average yearly salary of all 3 of these levels. So just go back through everything we just did using these new numbers. Okay. Sorry, I have some alarm going on. All right, sorry about that. I didn't want to pause because I'm not sure. I know the video stops and then it doesn't start again. So, all right, example 2, modeling attitudes of college freshmen. Bless me. Researchers have surveyed college freshmen every year since 1969. The graph shows the attitudes about some life goals have changed dramatically over the years. In particular, the freshman class of 2013 was more interested in making money than the freshmen of 1969 had been. In 1969, this is interesting, 42% of first-year college students considered being well off financially essential or very important. For the period from 1969 through 2013, this percentage increased by approximately 0.9 each year. This trend continues, if this trend continues, by which year will all college freshmen consider being well off financially, essential, or very important? Well, I mean, we all know in reality that we're never going to reach 100% of everyone because there's no way everybody thinks the same. But at first, let's go through the steps. The first step is defining our variable. So here, what are we looking for, right? Well, we have this graph. I should have shown you this on the other one too. We have this graph, and on our x-axis is our life objective, and on our y-axis is our percentage of people that find it very important, right? So x obviously is going to represent the number of years, since years is on the x-axis. So the number of years after 1969, when all freshmen will consider being well off financially, essential or very important, because everything is in terms of those people from 1969, right? Everything is in terms, both in the bar graph, you have the blue 2013 being compared to 1969, being well off financially and developing a meaning philosophy of life. Although I guess we're not doing that one. That one's probably the checkpoint. Okay. Step 2, represent the other unknown quantities in terms of x. Okay. Write an equation that models the condition. So here they have, I love this book. The problem states that in the 1969 percentage increase, that the 1969 percentage increased by approximately 0.9 each year. Okay, so here's the 1969 percentage, right? And we're adding 0.9 of an increase each year. So that part, going back to translating it to math, each year, okay, this is a rate. So they multiplied it by x, which was our years since 1969, okay? Equals, and what they're looking for is when will it reach 100%? Like I said, we're going to find an answer, but I think in the real world that answer won't mean anything. Okay, solve this equation and answer the question. So the first thing they do is they subtract 42 from both sides. Then they divide both sides by 0.9, and they say that x is equal to approximately 64. They used the real equal sign here because they have that repeating above the 4, okay? And they are rounding it to the nearest whole number, although I don't think they had to, because years can have portions of years. Like that's gonna be pretty close to 64.5 years. But let's put this back into, what does that 64 mean in terms of real world situation? It says after approximately 64 years, or in the year 2033, all freshmen will consider being well off financially essential or very important. Okay, so that's what it means, what we found. Then they go back and check. And in this case, they just substitute back in that 64 years where x was in the equation. Using the order of operations, they multiply it by 0.9 and then add it to 42. Okay, so again, just like I was saying, they come up with 99.6, which in the real world is not 100, right? Percent, and I'm not even sure it would get that close. It doesn't really take into account, you guys can always be skeptical of numbers in real world situations, and that is fine, and that is actually really good for everything. But that's interesting because this probably doesn't take into account things that have happened since, in the real world, since this book was written. Okay. All right, so this is just going over, remember when we talked about getting rid of fractions by multiplying the entire equation by a common multiple. This is talking about getting rid of decimals like this 0.9 to make solving a little bit easier. And all it's doing is multiplying the entire equation. So we're doing exactly the same thing that we did with the fractions to make it easier to solve, to get rid of, instead of 0.9, they want to make that 9, okay? So this is also, I feel like, not essential since we all have our calculators. So if you want to skip through this part, feel free. But all they did here was they multiplied everything by 10, both sides of the equation by 10. After they did that, instead of 42, they have 420. But instead of 0.9, they just have 9. And instead of 100, they have 1,000. When they solve the equation, they get the same answer. Okay, just with the number of calculators we have everywhere, access to calculators, I don't think that's as important as it used to be. But sometimes just nice to have better numbers. Okay, so here's your checkpoint. I'll help you get it set up. This time we're talking about the philosophy of life. Just like I said, I thought they would use the other one, right? And I'm going to skip down. Well, let's just read this together if you're having trouble. So we're talking about that same bar graph, okay? And it says that the freshman class of 2013 was less interested in developing a philosophy of life than the freshman class of 1969. So even though they're going up in how much money means, they're going down in developing a philosophy of life. I wonder if those are connected. In 1969, 85% of the freshmen considered this objective essential or very important. Since then, this percentage has decreased by approximately 0.9 each year. So we're going to subtract instead of adding 0.9 from each year from the original 85%, right? If this trend continues, by which year will only 25% of college freshmen consider developing a meaning philosophy of life? Okay, so we're looking for by which year will 25%. Okay. Example 3, so you guys take a moment and solve that. Example 3, modeling options for a toll. Oh, this makes me so mad about I-25 having a toll when we're all paying for the upgrades. The toll, so which means, you guys, that we're all paying for the upgrades through our taxes, but only people who can afford a toll will actually be able to use that new part of the road. That just toasts my buns. The toll to a bridge costs whoops, thought I was still in highlighter mode. The toll to a bridge costs $7. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $30, so they have to pay $30. With the discount pass, the toll is reduced to $4. This number reduced, probably we're going to have a subtraction sign somewhere. For how many bridge crossings per month will the total number monthly, sorry you guys, I got lost, cost without the discount pass be the same as the total monthly cost without the discount pass? So how many times do you have to use the toll for the money to make sense? So they're saying X is equal to the number of bridge crossings per month, okay, since that's how you pay for the toll. Represent other unknown quantities in terms of X. There's no other unknown quantities. Write an equation in X that models this condition. So they're saying, oh, so they're adding it to the other side instead of subtracting it. That's okay. The monthly cost without the discount pass is $7 per every time you cross the bridge, right? So up here we said X was the number of times you crossed the bridge. So if you have to pay $7 each time, that is 7X. When will that be equal to which means how many times you have to cross the bridge to make it equal to the $30 that you are adding on top of the $4 you would pay each time you're crossing the bridge with the toll. So with the toll, which is $30, you are still paying $4 every time you cross the bridge. So when are these going to be equal to each other? Then they solve the equation. So first they combined their like terms. So they subtracted 4x from both sides. They got 3x equals 30, divide both sides by 3, you get x equals 10, which means if you cross the bridge 10 times, it would be $70. You will pay $70 without the toll discount, without the toll discount pass, crossing the bridge 10 times, and you will pay $70 even if you buy the toll discount if you cross the bridge 10 times, right? But if you cross the bridge 11 times, it's going to be cheaper with the $30 pass that you bought. Okay, then they check it by substituting 10 back in, right? And they get 70 is equal to 70. They put the 10 here. They put the 10 here to get 70. Both sides of the equation are 70. It has balanced. All right, let me help you set up checkpoint 3. The toll bridge costs $5. So every time you cross the toll bridge, it is $5. Okay. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $40. So it's the same question, they're just doing different numbers. With the discount pass, the toll is reduced to $3 per time. For how many bridge crossings per month will the total monthly cost without the discount pass be the same as the total monthly cost with the discount pass? So our X is still equal to the number of times you're crossing the bridge. So every time you cross the bridge with the toll, it's going to cost $5. And we want to know, when will that be equal to crossing the bridge for $3? But you can only cross the bridge for $3 if you buy, so we're going to add on that $40 commuter pass. A price reduction on a digital camera. So we did, I feel like, a bunch of these when we did 8.1. Just to be able to solve those. So that's kind of funny that they wanted us to do section 8.1 first. So these should look familiar to you. And remember, the quiz 1, 60% is made up of these types of percent problems, okay? So this one says your local computer store is having a terrific sale on digital cameras. After a 40% price reduction, you purchase a digital camera for $276. What was the camera's original price before the reduction? So what we want to know is, what was the camera's price before the reduction? So what we want to know is what we're going to set up our variable to be equal to. Okay, there's no other unknown quantities. All we want to know is that X, writing an equation. So we take the original price, which is what X was, and we subtract 40% of that original price, and that is equal to our new reduced price. So follow along below how they solve that. I will also show you a different way to set it up. If the price of the camera is 40% off, that means we're still paying 60% of the camera. So you could also set it up as, if X is the original price of the camera and we are paying 60% of, which is times that original price, okay, our answer is 276. So you could write your equation either way. Basically, I'm just kind of doing this X minus 0.4X in my head. I just know if it's 40% off, I'm paying 60% of it, okay? Both ways you will get X was equal to $460. And then they check it. So checkpoint 4, after a 30% price reduction, like I said in my head, I'm like, well, if it's 30% off, then I am paying for 70% of the camera, which means 0.7 of the original price is equal to $840. Solving a formula for one of these variables. So this means that instead of solving an equation for a number, we just want to get one of the variables by itself, okay, to make it easier to solve. So in this particular one, let's just go, you can read through that if you like. Isolate 2L, we want to solve this for L, for length. So say we know the width, we want to solve it for length. I guess I never really do this because I can just substitute in and still solve for L after I add a number. But this is good to learn, especially for those SAT questions. Okay, so if we are solving this equation for L, we're just going to go through. They want to, L is right here. We want to isolate it. If we're solving for L, we need to get L by itself. We need to isolate it. So the first thing they do is they subtract 2W from each side, okay, which cancels this out. And now on the other side, you have P minus 2W, and on this side, you just have 2L. Well, then we need to separate that 2. 2L means 2 times L. The inverse operation is to divide by 2, so we just divide both sides by 2. And this is easier than using numbers because we don't even have to simplify this, right? We're done at this point. L, after we divide by 2, L is just equal to P minus 2W divided by 2. Okay, now try the same thing for W. And here they want to solve this for P. Solve for P. So the first thing they do is they subtract D from each side, which just gives them T minus D equals P times M. To get rid of the M, we use the inverse operation divide. We divide both sides by M. P is by itself. P is just equal to T minus D divided by M. Please try checkpoint 6. All right, you guys, we are done. Thanks for playing.